All right, so we wanted to do a session that involved a slightly higher level concept, in this case, kinetics, but we also wanted to use a device that maybe was a more accessible to teachers, and that is we're going to use this colorimeter to do the experiment today, and it comes in two parts. We're going to use the colorimeter to determine lambda max, and then later we're gonna use it in time-based mode to determine the kinetics of the experiment. So if we look at the goals of the experiment here, one thing to think about is, why would you want to do this? Well, in the last 10 years or so, there have been every test has AP test has questions on kinetics. Here's a couple of pre-response questions that I dug up from the archives, and you'll notice that lambda max is mentioned, as well as the kinetics graphs to determine the order of the reaction. So our goal today is to do both of those things using the colorimeter. So the experiment can be done with a spectrophotometer, and certainly your full spectrum will look better on a spectrophotometer. But I'm going to show you the poor man's way to do a spectrum using just 4 wavelengths, and that's the key to our activity today. There's also a group of files that will be available to you that you can download that has all the instructions. So I don't feel like you need to take any notes or anything right now. This link will be provided, and you can download all the instructions. You can also download sample data that's in a folder, as you can see there, and also a calculation spreadsheet that allows you to convert absorbance values to concentration. Some teachers prefer that, and so that will be available to you too. So here's our goals for today. We're going to determine lambda max. We're going to find the order of the reaction, and we're going to determine a rate constant so we can write a rate expression similar to the one you see there on the screen. So let's do a little experimenting here. I'm going to bring all this equipment up to on a camera, and so you guys can see what I'm doing. I'll also have a copy of Graphical Analysis going here. If you're connected remotely, then you can also get the data live from me as I collect it. So here's the plan. The colorimeter has 4 wavelengths, and that's what we're limited to, just 4 wavelengths on the colorimeter. And so we're going to test every single one of those with our blue food color. So I've already previously made up a sample of food color that has an absorbance that's greater than 1.5. And we'll talk about that. That becomes more important when we do the kinetics side of the experiment. So let me connect the colorimeter to my copy of Graphical Analysis. Any Go Direct sensor can be connected by Bluetooth or by USB. I'm going to press the power button, and what will happen is an LED will start to flash. It indicates that it's ready to connect. I'm going to click on sensor data collection and find this device, and so there'll be a list of them there. The one I want will have an ID number that's unique. And so if I look on my colorimeter, my ID number ends in W4. If you can't find it right away in your classroom, you can filter down the list like I just did, and we'll be ready to collect data. Not quite. Look at the graph. It says time on the x-axis, and unfortunately that's not going to be useful for us because we want to compare the wavelengths. So I'm going to change the mode of data collection. Bottom left corner, there's a box that says mode. I will tap there, and then I will change from time-based to event-based. In this case, the event will be the wavelength of the LED we're using. See if I can spell length. There we go. And the units will be in nanometers. Okay, so I'll tap done. You'll notice that now the graph has changed the looks a little bit. In events-based data collection, there is no anxiety, no hurry. You can start collecting data anytime you want. You'll notice that now there's a new button up here that says keep. It's waiting for me to tell it to keep a value. Actually, I'm going to turn on a meter, which I neglected to do. I'm going to turn a little meter on here, make it a little bit easier to see. There's a small one at the bottom, but I kind of like having that big one there. It's just easier to see. So let me start collecting data again. What we need to do is pick a wavelength, and you'll notice that the devices by default pick the lowest one. Honestly, it doesn't matter which one you do. I'm going to be a little OCD here and start with the lowest one and work my way up. We're going to need two cuvettes. We're going to need one with the sample. We're also going to need a cuvette for water. So technically it's called the blank. And so our cuvettes, two sides are clear, two sides are cloudy. The idea is that you want to line the clear sides up with the light path going left to right. So I'm putting the blank in. And what I'm looking for is this value of absorbance to be reading 0. If it was not reading 0, I would push the cal button. I'm going to do it once so you guys can see what happens. A little LED is flashing here. And what it's doing is it's actually doing 100% transmittance, 0% absorbance. It's calibrating that for us at this wavelength, 430 nanometers. So I'm going to take that blank out, and I'm going to replace it with some of our blue food color. Now, those of you that are familiar with our spectroscopy devices may know that we recommend that you not exceed 1 for absorbance values. And that's particularly important when you're doing experiments like Beer's law or something like that, where you want the absorbance to be directly proportional to concentration. However, for this experiment, we need an absorbance that's high to start with because we're going to dilute this in the second half. We're going to mix it with bleach and we're going to be diluting it. So that's why the absorbance needs to be so high at lambda max. So I watched that reading. When it has stabilized, I tap keep, and the software says, well, what wavelength are you at? Well, that's 430 nanometers. So I'm going to keep that. Now what I'm going to do is take out the sample. I love these cuvette racks because I tend not to trust myself, and they hold the cuvette so beautifully. Put the blank back in, advance the wavelength to the next choice, which is 470 nanometers. I'm watching that absorbance, making sure that it's reading 0. It is reading 0, so I don't necessarily need to calibrate it right now because it looks pretty good. Let's put the sample in. We'll wait till that stabilizes. As you can see, this blue food dye does not absorb very well at 470 nanometers. Let's tap keep and type in the wavelength of that LED. And then we'll progress to the next one. So the process is pretty straightforward. Put the blank in, move to the next wavelength, observe the absorbance value. Looks pretty stable. Doesn't hurt anything. You can always press the cal button. It just takes a few seconds for it to calibrate. And so good technique might be for your students is go ahead and push the calibrate button every time. But they should also understand that the whole point is that with the blank in there, the absorbance should read 0. So that's good. Let's put the sample back in. And now let's read the absorbance. And at 565 nanometers, the solution does absorb a little bit. Wait till it stabilizes, tap keep, type in our wavelength, 565. And then one more. We'll do the last wavelength on the device, 635 nanometers, move it up there. Check that absorbance value. Looks pretty good. Take out the blank, put in the sample. So when I set up this blue food dye, what I did was I did it at 635 nanometers. Of course, you can see how well it absorbs. And I purposely made it very dark for the second half of this experiment. And when we do the second half of the experiment, we're going to dilute this with bleach just simply by mixing it. And that's going to drop the absorbance and a lot. And to get good data, we need to start the second half at a very high absorbance. I've done all three. I'm going to tap stop. you should be getting these points on your end. You can see that they appear as points. Since you all have Graphical Analysis Pro and I have Graphical Analysis Pro, we could make it look a little bit more interesting by using the bar graph feature, which is part of the Graphical Analysis Pro feature set. If I tap on the little graph icon, bottom left corner, graph options, can go down here and choose bars instead of points. And I just think for this type of graph, it's very appropriate to have a bar graph sort of thing. It's a little more visually interesting. And you can see that, well, this is the discussion you probably should have with your students. Which one of these LEDs, these wavelengths, do you suppose will be the most appropriate to do the second half of the experiment? And so we would probably gravitate towards the 635 nanometers. Now, is this the true Lambda Max? Not really. If you looked at the spectrum of blue food color, it actually maxes out around 630 nanometers. But since we are limited to 4 wavelengths, we're going to use the 635. It's going to be slightly on a shoulder of that graph, of the absorbance graph, and it's going to work perfectly for us to collect data. So this is how you can use this device to do a poor man's 4 wavelength spectrum, and then at least decide for other experiments, maybe a Beer's Law experiment or for a kinetics experiment or an equilibrium experiment, which wavelength we should focus on to do the second half of the experiment. I'm about to start part 2, and so at this point, if you want to keep a copy, if you've been collecting data with me live using your Pro copy of Graphical Analysis, this would be the exact right time to go to the File menu and save your data. So if you want to save the data that you and I just collected together, this would be the perfect time to do it, okay? Because we are about to start a different experiment. And the meter temporarily, just so get a larger screen here, larger graph. And what I'm going to do is, one of the features of Graphical Analysis Pro is the fact that you can create bar graphs. So if you want to do it on your end, I think this echoes over if I remember correctly. I'm going to tap on the little icon bottom left corner that looks like a graph. And I'm going to go down to where it says graph, edit graph options. And I'm going to switch to bars. Now, I got a feeling this is going to echo, I think, if I remember correctly. Yeah, I see it on my phone. So I'm going to give you guys a chance to try stuff on your own later, but it's kind of nice. Hey, Noose, there's a bar missing. No, there's not a bar missing. Remember the absorbance at 470 nanometers was really, really low, and so now it's a discussion of which one of these should we use for the second part of the experiment, and the students found it for themselves. So kind of a poor man's spectrum. It's not ideal, but with this device, it's perfect for this experiment. Now, I'm pushing along. I apologize for the bum's rush, but I tend to talk a lot, and Melissa and my teammates will sometimes try to rein me in. So if you want to keep a copy of this data on your device, go to the File menu, top left, and go down to Save. Because in a minute, I'm going to change the experiment and you will lose your wavelength. Okay, pardon me, I was reading a comment. You will lose your data when I change the experiment. So if you want to keep a copy of this for yourself for later to review, this is the time to do it. And this gives you a chance to look at how graphical analysis saves things depending on your platform. Apple users, iPhones are dear to my heart. It will take you a minute to figure out how to get this data. So it might be worth doing that. We're not going to spend any time with that now, but if you get stuck, give us a call or send us an email. But save this if you want it, because we're going to change the experiment. Okay. So part 1, we now know that 635 is a good wavelength to use. Let me get that cuvette out. And so now what I'm going to do is I am going to change the experiment. So I'm going to go up here. You're going to get a notice in a minute that there's a new experiment happening. So just be aware of that. I'm going to start a new experiment. Melissa, is there anything I need to know before I get going?
I'm just going to interject while you're setting that up. There's some questions about the Lambda Max and all that. Because we are using a colorimeter, right? We only have 4 wavelengths. So we pick the one that gets the most absorbance. It may not necessarily be the Lambda Max, but you don't have to use the Lambda Max for these experiments. You just want to use one that's going to give you a high enough absorbance that you can actually see a change over time. So the colorimeter cannot do a full absorbance versus wavelength scan. It's just a colorimeter. It has only 4 wavelengths. If you have a spectrometer, you can do the full absorbance versus wavelength, which is the advantage of having the spectrometer. And that's why we've done some webinars and some talks with the spectrometer, but a lot of people can't afford a classroom set of spectrometers. So it's really nice to either do it this way with all of your students, or you can have one spectrometer, show them the true Lambda Max, have them do it with the colorimeter, discuss the differences, discuss why it'll still work with a colorimeter, and then have your students still get that hands-on experience.
We sometimes call that faux Lambda Max, we call it the shoulder. So if you look at the blue food color with a spectrometer, you'll see that it actually absorbs best at 630. And so 635 is just a little past there, but it's still hot, very high, and will give you valid data for Beer's law. It'll give you valid data for what we're about to do. It works fine for equilibrium. So it gives you an option, but it's not the peak. Okay, but it is the Lambda Max of the 4 that we're looking at. So little semantics thing there. All right, let me see. Last time I did this, I left a cuvette in there. I have the blank in there. I was checking to make sure that I'm reading 0 at 635 nanometers. Okay, so that's good. Let me bring that blank out. Now, kinetics. What we're going to do is we are going to take some blue food color, which I previously made a very high absorbance, and we're going to take some diluted bleach. Okay, now you need to try this on your own. Okay, depending on the bleach and what's in it, I would try to avoid bleaches that have like detergents in them. That will cause you some strange results. You are probably going to have to dilute this. This diluted from this Clorox, it's 10-1. Okay, I did a little bit of testing to make sure this was going to give us good data. So the night before, whatever you need to make up this bleach solution and the food color solution. And yes, this will work with other colors. Best results with blue. I've been getting red works okay. Green is unusual because it's got blue and yellow mixed in. Anyway, here we go. So this procedure is step by step in the handouts. So just be aware of that. What we're going to do is equal volumes of the 2. So we're going to take 10 milliliters of bleach, diluted bleach, and put that into 1 graduated cylinder. And then we're going to do the same thing with the blue food color. So let's put that into another graduated cylinder, equal volumes. Now, one thing to think about here is what is the concentration of these 2? Well, the bleach, when you buy it from the store, it's, I believe, 0.8. And that's way too strong, of course, so you're going to dilute it by a factor of 10. But the food color is 4 or 5 orders of magnitude less concentrated. So we are going to focus in on the food color for this reaction. Sometimes people call it the pseudo rate law because we're only looking at one reactant. So let me get all this stuff lined up so you guys can see what I'm doing here. Now, the tricky part of this is that you got to do everything kind of in a methodical way. And your students are probably way more methodical than mine were. And so here's the thought. We're going to mix the 2 in the beaker, little swish. We're going to put it into the cuvette, put it into the colorimeter, and then when the absorbance gets to the highest value, we're going to hit collect. Okay, so all that has to happen in a smooth way. So I'm going to put the food color into the beaker. Now here's where the fun begins. Soon as I pour the bleach in, then the reaction is going to start. So that's where you need to be can't be talking to your friends about what you're doing tonight. Okay, things will mess up. So here we go. I'm going to put the bleach in, give it a swish, fill the cuvette. I'm going to trust that I don't spill it when I put it into the colorimeter. And then I'm watching that meter. When it hits the max, I'm going to hit collect. And you should be getting data on your end. Now, what I like about this is we have a visual cue right here, right? So we've got, the mixture is still happening here. You can see the data appearing on your screen. Hopefully, if you're collecting data with me, you're getting it. By the way, there is sample data in that folder. And so what I like about this procedure is, because I've seen people do it where they mix it in the cuvette and stuff, and that's nice for small amounts, but then everything's happening inside this black box. What are we seeing here? We're seeing the absorbance drop. Well, as we watch, it would have been smart, Melissa, if I put this on a white surface under here. Wouldn't that have been smart? Don't accuse me of being smart.
It'll get low enough absorbance. We'll still be able to see it.
It will be. That's true. And so now another couple of things. You notice that I did not mess with the data collection this time. The colorimeter defaults to 300 seconds. That's great for every trial I've ever done. The one thing you want to think about is when you get down below absorbance of 0.1, now you're getting to where absorbance and transmittance, the logarithmic function that relates those, is starting to become a factor. So when you do this, you want to watch the absorbance. When it gets down below 0.1, you want to stop collecting data. The colorimeter will probably drop off if you try to get it too much below that. And your plots are not going to look very good. The other thing is, I have had teachers say, I'd like to write that rate law with a concentration instead of with absorbance. Well, a couple of things to think about. One, Beer's law says that the absorbance and the concentration are directly proportional. So it won't really matter well, this, but your two students know in a first order kinetics, X is going to equal 1. So it doesn't really matter what we use. But if you want to be true to form, there is a spreadsheet in the shared folder that shows you how to use Beer's law. Absorbance equals epsilon LC, right? The molar absorptivity, path length, and the concentration. It shows you how to calculate the actual concentration. And in graphical analysis and also in spectral analysis, you can set up calculated columns and you can have it plot concentration instead of absorbance, if that floats your boat. So you have that option, and I put that in there because I've had enough teachers ask me, can we change that? Of course you can, but it takes a little bit of manipulation. So I'm getting close to 0.1, and so I right around now would be the perfect time to stop collecting data. Maybe if you're OCD, you let it go. With this setup, I might let it go all the way to 200 seconds. Doesn't really matter, but I'm going to stop collecting data in a second. So watch your screen, and then I'm going to disconnect from you guys so we can do the last part of the experiment. So I'm stopping collecting data now. Okay, and so now the question is, and if you go back to that AP question, it's pretty common, and that is, oh, by the way, Melissa's right. Look at the beaker, right? Isn't that pretty? Right? I really love that. But anyway, let's look at our data. Okay, first thing I'm going to do is I am going to disconnect from you. So you're about to become on your own. So I'm going to go up here to the right where that little TIE fighter is, and it says that I have a data sharing session going, and I am going to disconnect. I'm going to stop sharing so you can watch me or you can follow along on your device. Okay. What do we want to do? We want to figure out what the value of X is. So if you look at the rate expression, let me bring it back up here. We want to know what X is. Okay. So, is it a 0? Is it a 1? Is it a 2? Well, if it was a 0, this graph would be straight. So it's obviously not zero. So let's test and see if it's first order or second order kinetics going on here. First order would be double the rate, you double the concentration, it doubles the rate. Second order, you double the concentration, quadruples the rate. Let's test that. So you got to follow along here if you want to see exactly what's going to happen on your end. I'm going to turn the meter off. I don't need it anymore. And I'm going to turn on a data table, because what we'd like to do is do a calculated column. Pretty common question, especially Logger Pro users that are now getting Chromebooks in their schools and they're all, like having to use graphical analysis. Can we do what's in Logger Pro? Absolutely. On your data table. So I turn the data table on by tapping on this view options box in the top right corner, turned on the data table. And so once the table's on, right next to absorbance, tap the three dots and do an add calculated column. So to test for first order kinetics, I'm not going to go through the whole lecture right now. We are going to take the logarithm of the concentration, or in our case, the absorbance. So that's going to be the name of our column, and no units for log. And then down here, by the way, just take note, this is where you would adjust significant figures, scientific notation. If you were doing this thing in concentration, you would definitely have to use scientific notation because it's 10 to the minus 5 molar. Down here where it says insert expression, I tap there and I'm looking for a log function, natural log, and there's one right there. So I'm going to use that. Just verify a couple of things. The parameters are always set to 1 by default. You can change them if you need to. And then you want to make sure that we're actually doing the logarithm of the absorbance. If yours says something else, tap on the little box and you should see absorbance pop up there. So there we go. It's ready to roll. Let's hit apply. And oh, noose. Where the heck? Tap on the little magnifying glass in the bottom left corner. You can also double tap the graph. Ah, there it is. Well, it's not bad. Let's take a look and see, how linear that is. Tap on the little graph options icon, bottom left, the little mini graph. And this time, let's choose apply curve fit. Let's see how linear this plot is. And so linear pops up by default, but there are other fits. We don't need them right now, but if you tap where it says linear, that's because 80%, 95%, I don't know, of the time you need a linear fit. We'll tap apply, and it tells me, oh, look at that. So R, correlation coefficient, tells me how close the data is to actually being on a straight line. And in this case, the best value for that is 1. Absolute value of 1. And so I have what's known as 4/9 correlation. This data is very linear, but let's just humor the instructor and check second order kinetics. So we're going to do the same thing. We're going to tap on the absorbance, the 3 little dots next to absorbance. We're going to create another calculated column. So choose that under the 3 dots there. And this time, the function that we want to test is the inverse of the concentration. But in this case, we're using absorbance to stand in for that. And then down here, we need to find an expression that does 1 over or inverse. And sure enough, right there, the second choice. By the way, I'm almost done with this sort of thing. I just want to point out that since you have Graphical Analysis Pro now, you can put in custom expressions. You don't need to for this experiment. Everything we've done in this experiment, you could do with the free version, except the bar graphs, you'd have dots. So anyway, let's pick A over X. A should be 1, X should be the absorbance. So if you need to adjust that, just tap on the box there and make sure you choose what, the one you want, and then tap on apply. Oh, that doesn't look very good. Anytime in graphical analysis, you need to adjust what's being displayed. I'm going to turn off this fit temporarily. Tap on the Y-axis label, and you can turn on or off whatever you want to look at. I want to look at 1 over absorbance. I don't want to look at the linear, or pardon me, the log. And so, yeah, that doesn't look too linear. Hey, Noose, it'd be really neat if we could see all 3 graphs at the same time. I'm going to turn off the data table. We're done with it. So top right corner, I can turn off the data table. And what I want 3 graphs on the screen. I want to look at all 3 of them at the same time. And I'm, once again, as you might have figured out, I'm a little bit OCD. So we're going to put the original plot at the top. So I'm going to tap on the y-axis label and put just the absorbance up there. And then in the middle graph, every graph is unique. So in the middle graph, I can plot the log. That was the first order test. And then in the bottom graph, I can plot the inverse. That's the second order test. And you can put titles on the graphs. They're totally independent. So since I want the rate constant, it's going to be the slope of this middle graph. Let's do a linear fit. You remember how to do a linear fit? Tap on the graph options icon and choose apply curve fit. And tap apply since it's defaults to linear. And that slope, in this case, minus 0.01277, that is K. So if we go back to our rate, remember I told you in 40 minutes, we're going to do all of kinetics. So rate equals, in our case today, negative 0.01277 times blue food color raised to the first power. Now, if my students do that, they would lose a point. And if you read the test, the students, what am I referring to? Anybody know what I'm referring to? Why, if they just put the slope in there, would they lose a point? You're welcome to throw it in the chat. You're welcome to correct me if I'm wrong. Well, the negative slope is a discussion, right? I mean, the concentration is going down, so there's that. The other thing is the units. One of the things they have to have is a rate constant has to make it so that you actually end up with a rate. So a rate is molarity per second, and absorbance can stand for that because it's first order and directly proportional. But if you look at the right side of the equal sign, you've got molarity times K. How do we get molarity per second? Well, the K has to have the units of 1/seconds or seconds raised to the -1. And in the AP test, they don't lose points, they just don't get the point, right? So if the rate constant was worth 2 points, they would only get 1. Because they forgot to put the units on there. So yeah, they can do that, and they would have to know to do that from the fact that the x-axis is in seconds. How are we doing? How are we doing on time, Melissa? Am I okay?
Yeah, you're doing pretty good on time.
Oh man, I'm glad to hear that because you know how I can get.
Yeah, could you go back over? We're having some questions about how to change what's you're seeing on the graph. So could you go back over?
Such a common question too. You know, we get this call all the time. My kids did all this work. Anytime you want to change what's displayed on graph and graphical analysis, tap on the label for that axis. And that applies to the x-axis as well. You know, you can change what's plotted, and you can turn on and off whatever you want. You can also change the colors. If you tap on this little point protector, you can pick a different color. I mean, green and blue, that's not too bad actually, but it would be nice if one of these was red. Let me go to the bottom one and I'll make that one red. So but yeah, you can adjust, you know, not only what's displayed, but you can also adjust how it looks from there. Since we have the time, common question. How do my students make a report out of this? Well, this is where Pro is going to stand out a little bit, but it's a minor thing, but let's take a look at it. Honestly, if you're on a phone, I would take a screenshot. It's just the easiest way. Once you got everything the way you want, like my students, I would expect them to title the graph. So in that graph options menu, when you hit edit graph options, this is where the title should go. So this one is my first order test. You know, and you could, if you're a real purist, it would be like, you know, log absorbance versus, you know, the dependent versus the independent variable. So, you know, students should probably, you know, title their graphs and things like that. But when you want to create a report, if you're not going to take a screenshot, what you can do is you can go to the file menu and you go, this is a pretty common call or email. Where's the print option? Folks, think about what it takes to print on every possible platform in the world. It's near impossible. So what we do is we give you a free and a paid for. Let's take a look at it. Go to export. And you get two different ways to get a graph out of here. One way is to do PNG files for each graph. Okay, that's free. So the free version of graphical analysis, you would see this. We are working with the programmers to see if we could get something done here where that you could maybe move that data, with a statistics box. The Pro version gives you the option to create a PDF. A PDF will create one file that has all of your graphs in it at the same time. And so, there's two of them, and then so it's one file instead of two. I'm not sure I would pay for the Pro version just for this feature, but it's nice to know that that's something that comes in the Pro version. If you try to do that with the free version, it'll just say you need to, I don't know, pay money or something. The CSV will let you create either Excel or Sheets files that you could import. You can also import them into Logger Pro if you're dead set on using Logger Pro. AMBL is the old file type version of graphical analysis. Probably going to end up going away at some point because it's not too horribly useful, but there's once in a blue moon where it's useful. The other thing you can do, and sometimes when things look ugly right now, you change the shape of the graph and it can make it look a little bit better. These PNG files are standard. So you can either save them or you can make a copy. It's got a little copy tool down there and then paste it into your favorite editing program. My students, the last 3 years I taught forensics, and my students were giving their reports in Google. What's their PowerPoint program called? Slides, right? And they didn't do this because we were on the Max with Logger Pro, so we were doing, but the same idea. We were taking pictures or PDFs or whatever, and then just pasting them in. Well, this is even easier because when you click on the little copy icon, now that thing's in memory. Drop it into your favorite editor. You can print it too if you want to do that. The PNGs are standard file formats. I don't remember printer graphic. I don't know what N stands for. Any other questions?
Nothing else has come in. Feel free to ask more questions. We have a couple more minutes.
So let's see. Did I have anything in here? No. Okay. So a couple of things to be aware of. There will be a recording of this if you want to try to follow along on your own, maybe in your classroom or something. The other thing is there's three of us in the chemistry group. We know each other pretty well now. I've been here for 6 years. And so when you write to chemistry@vernier.com, you're going to get one of the three of us. You can call and talk to us. We're happy to talk to you and walk you through stuff. And so one of the things that always stood out with Vernier while I was teaching was you call and a human answers the phone. What's that all about? You don't get a voice. I mean, unless you call. We are 3 hours behind the East Coast, so that you East Coasters, you might want to be aware of that. I couldn't call Vernier first period because they weren't open. I had to wait till second period. First period plan. Man, I could never I had to email them. But any thoughts? Anybody have do you teach kinetics? Would you do this experiment? What do you think?
Yeah, a couple people have said they like it and they're gonna try and put it in their curriculum. So that's great. It's a good way to teach kinetics.
Yeah, this version is pretty straightforward. Crystal Violet is wonderful. We've all been doing it for years. I didn't know that you can buy Crystal Violet in like stores. It's some kind of a medicinal thing. What about red? Yeah, sure. I mean, I tried this with red. I basically wrote the experiments you're going to get from the downloads are from the new forensics book that I'm writing. And I started with a red fluid, and my inspiration was the Die Hard movies where they have those bombs, and when you trip the bomb, chemicals mix and a reaction occurs, and it was a red dye. And it works fine. The thing about red dye is it's pretty light sensitive. And so if you leave it sitting around for a while, it'll start, acting up on you. I seem to get better data with blue, but red, it would be interesting to have different groups do different colors, right? If you buy the dye kit from Flynn, you get 7 colors. And they're the approved FD&C food dyes. The dye kit, by the way, folks, it's you're only going to buy one for your school for 20 years because it's such a small amount of dye you actually need for an experiment. So. Yay, Karen. Thank you. If you have any issues with them, you just saw how they work. I love them. You can do a lot of things. I wrote an experiment called poison wine. Melissa's used it. I've used it. Doesn't work for that experiment because you need a full spectrum. But the second half is Beer's law. So you could do a demo if you happen to have one spectrometer and do the full spectrum to determine where the poison is. But then you could do the Beer's law part with your colorimeters, and it works great. I actually posted an article years ago about how do you get by with just colorimeters, or maybe one spectrovis, and then the whole class was colorimeters. So yeah. I just had a customer ask me today, well, how long do you repair colorimeters? And I will tell you right now, we will help you with your colorimeters for a long time. The big thing with them is the LEDs may start to get a little weak, but it'll take years. I mean, those football colorimeters, I had a whole class set of them, and they were working perfectly when I left, my school. So I guess we're getting to that point. Dylan, did you have anything else you needed to say before we close it up?
I just went ahead and dropped a link to a quick survey that you all can take into the chat. We would just love to get some feedback from you, get to know, what you liked, what you didn't like, what you're looking for in the next webinar. So I'll repost that link. No pressure, of course. We would just love to hear from our people. We want to give you webinars that you want to attend. So thank you.
Let us know if there's any topic that you would love to see and share. Let us know. I'd be happy to put it together for y'all. Melissa's, I tell you right now that CVS, when I first looked at it, it's like, why would I ever? Well, for your own understanding of what happens when you change the voltage and the current on an electrochemical reaction, and how does that drive the reaction one way or the other? That blew my mind away, and it uses such simple chemicals. So I hope you take a look at that, even if you don't happen to use that device, just for your own background. I think you'll find it's very informative.
Yeah, and those of you asking about some of your repairs, you're not working sensors, definitely shoot chemistry an email, chemistry@vernier.com. Also info@vernier.com if it's not a chemistry sensor. But please, please, please don't try and repair it yourself. Call us up. We're happy to walk you through the troubleshooting. And like Nus said, we try and repair sensors even well after the warranty is gone. And thanks again, y'all. I'm glad to hear all the positive feedback for our webinars. Yeah.
All right. Bye, everyone. Thank you.
Bye.
Bye, everyone.